Hello guys, this is me Sulav. So today I'm going to solve a problem which has been asked to me actually in a Google phone interview recently, and actually I was not able to solve the problem there. So I thought it would be a good thing to share my experience. So the problem was okay, so out of two questions during a 45-minute phone interview, technical phone interview, two questions were asked, and this is the second question they asked me. So the problem was we will be given a function which generates a random boolean value. So the function given to us will generate either true or false randomly. Okay, so using that function and without using any of the inbuilt library function, we generate random number. Like we can write our own algorithm or logic for generating a random number, but we cannot use the library function like uh, math dot random function from the library of Java. So we can use this random function, and we have to generate random number between random integer between 1 and 20 inclusive. So it has to be 1 inclusive and 20 inclusive. So we have to generate these 20 numbers randomly. We should have equal probability, so we cannot generate like what I did in the interview was I wrote a function in which the likelihood of getting a 1 is very less. So like uh, when I ran around 1000 iteration of my function, I could hardly get one or two outcome for one. So that was a wrong implementation. I can so share that implementation, but that won't be useful anyway. So I'm going to write this function. Okay, so even though the function which generates a random boolean will be provided, I will just for clarity I'll just provide its implementation as well. So that function should return random boolean. Okay, so this function can use the inbuilt Java library function, right? Because this thing will be provided to us, and when they provide us this method, they could have used any method they want, right? So I think this thing is obvious. Return, we can do is math dot random. So this will generate a math dot random will generate a number between 0 and 1. Is it, yes, 0 and 1. So we can do like this 0.5. Okay, so what this does is this is not the part of the question, even though I'm like explaining it as a bonus. Math dot random will generate a number between 1 and 0 and 1. So if the number generated is from 0 to 0.5. Okay, let's do this. Is from 0 to 0. Is from 0 to 0.5, we get false. And if it's greater, if the number generated is greater than greater than or equal to 0.5 till 1, then we'll get a true. So this will generate a random boolean. Okay, so now let's come to the problem. So the function which we are going to design can be private. Let's make it static. It has to return integer between 1 and 20. Okay, not 0 and 19. That we have to make, like, that we have to think clearly. Let's name it rand int. Okay, so out of many approaches for finding a random number, what I like thought of after the interview, obviously, because I could not think of this solution during the interview. Actually, this idea was given to me by my wife Asta. So after the interview, I asked her, if you were asked this question, how would you approach it? So she just did not give me the whole program or the code. She just gave like suggestion or hint kind of thing. If it was me, I think I would have used the bit position till number 20, and I would have tried something. So okay, let me explain to you. Okay, so we have to generate a number between 1 to 20. Okay, and 1 means in binary 1 is 1 only. So this 2, we have to go 20. So 20 is 16 8 4 0 0 1 0 1. Yeah, so we have to generate a number. See, I think now you can get the picture of like you can guess what I'm trying to do here. We since we have a number which generates random boolean. Okay, random boolean will generate either true or false. So considering 0 as false and 1 as true, or okay, to make it more clear, I will write a simple helper function private, which will be static int rand let's say 0 1. This will generate a random number 0 or 1. Using this will generate true or false, this will generate 0 or 1. Okay, this is just a helper function. So what this will do is return. Okay, so if this is true, return 1, or return false. Okay, so instead of returning boolean, this will return 0 or 1, as clear as that. Okay, so now you can make use of this rand 0 1 here. So we have 5 position because this is number 0 and this is number 20. So we can generate like bit combination for in 5 places. Okay, 1 2 3 4 5, and each like for 1 bit position we have this function, right, which either generates 0 or 1. So in the way, if we write a function which will generate 5 random bits. Okay, 5 random bits, and we arrange it in this manner by any logic. Like we can multiply each, like first of all we generate the first number, like the first number, multiply it by 10, and then add another number. I mean add again a random 0 and 1, multiply it by 10, and add another random number, so on. Okay, so we can do that. I think I'll add a program so it will be more clear. Okay, so what okay, so let the number be num. Okay, so the number, the for initially the we can take it as rand 0 1. So this is the now first number. So this will be the number in the like leftmost position. For that, what we can do is we can because we can write 5, like 5 different statements, or we can write for loop int. I prefer writing I as the loop index, so I will be less than. Okay, so we can see here there are 5 bits. That's why we have to like generate 5 random bits. Okay, so here we have already generated 1, so we need 4 more. So 0 1 2 3, 0 2 3, or also we can do this I plus plus. Loop runs 4 times to make it clear. So what we can do is num into equals to 10. Okay, so num equals to the no, when the loop runs for the first time, that is when the value of I is equals to 0, we num equals to this number times 10, times 10 plus this number times 10 plus this number. Okay, so again a number. Okay, so what this does is, suppose in the year, like when you run the loop once, if this had generated 1, and if this has if this second call, this is the first call, and the second call to rand 01 generates, let's say, 1, then after this statement has executed, the result would be equals to uh, this 1 times 10 plus this, so 11. Okay, so if this was 0, we would have got this first number times 10 plus 0, so 10. Okay, so on. So this loop runs 4 times, and the last time I am explaining, first of all, this line generates the first bit, and we multiply that number by 10, and add another random bit. Okay, so in second loop we add 10 to it, and sorry, we multiply it by 10 and then add another random bit, which is this. So on, we do this four times in this loop and 1 time outside, so altogether 5 times. So what, like, by the end of this for loop, we can get a number between 0 to 11111, because like, it can so happen that this number may have generated 1 each of the uh, 5 times, 1 time here and 4 time here. In that case, we get number which is this. So and this number is more than 20, right? It is 1 2 4 8 16 32, maybe 31, right? So we have to ignore that number. So what we can do is, if number is greater than 10 24 10100, so if the number generated is greater than this number, we can again run this loop again, return rand int, like we will recursively call this function again, like until, and if else, that means if the number is not greater than 20. Okay, what now happens is, this number has generated numbers, like numbers in this format 10100. Okay, these are binary numbers, so we have to convert these this num into a decimal format. So what we can do is, declare return %. Now this is a hack. There can be other method to do it, but true. So what this parseInt does is, it will take 2 parameters. The first one is integer, sorry, is a string which represents the integer in this index. Okay, so digit, so this parameter should have the string representation of a binary number, and here I have just added plus and like empty code, so that this number, this integer, will be converted into string, and this is the 2, that is this is the index of this number. So this way, this is just a hack. There may be other way of converting a binary number to decimal number, but this is just a hack, because I just remember this function. So and this will convert this binary number into decimal number. So okay, I guess this should work. So let's try one. Okay, uh standard rand int. Let's see what we get as a result. 19. Okay, 16. Okay, I just want to make sure that our random number generator. Okay, so just now we got a number called 0, right? Before this iteration, I mean before this run, but we don't want, we just want a we just want number between 1 and 20, not uh, 0 to 19 or 0 to 20. That's what I was talking about before. Now we have to take care of one more thing. What we can do is, uh, let's do this. We can generate a random, we can generate a random number between 0 to 19 and then add 1 to it. That should work, I think so. Okay, so 19 means 0 1. This should be 19, is it? Because 16 17 18 9 20 1 1, sorry 1 1 16 17 18 19. Okay, so 4 times, if the number is greater than we need a number between 1 0 0. Real number we should be max 19. Okay, even though, okay, there was a mistake again. I just didn't want to show you the complete code in the beginning. I just wanted you, like, wanted to walk you through this code thinking process. So we need a number between 1 to 20. Okay, but this program will generate a number between 0 and 19 now. Okay, so 0 to 19, and the number thus generated, we can add 1 to it. Okay, so this is not a nice way of doing it. Okay, let's check it. Okay, we can check this function, like we can run this function as many times as you want, but a better way of testing if this program runs or not is by writing a, okay, I'll just write write some lines of code. It will be a hash map of integer. This hash map will keep a count of how many times the numbers has been generated. So integer, let's name is rand hash equals to new hash map. So I think I won't explain this code to you. I'll just write these lines for is equals to 0 j. Let's run this 1000 times and see like what result we get. Random equals to rand int if now we will place this generated number into the key of the hash map, and we'll keep a count of that. So, let me just write this function first and then I'll explain it to you. Rand hash dot put, what it will put, rand num It will increment it if it's already there. Rand has dot get random one if it's already present. If it's not present, then it will create new entry, put who's value. Now we can print the output. I mean, we can see how in the end what the hash map will look like. So we will just get all the entry set, use lambda for each entry, system print ln entry dot get key. So could do this, get value. I guess this should work. Close this. Okay, so okay, I'll explain to you. So what I'm trying to do is I'm creating a hash map which will have key and value. Okay, so the key will be the random numbers generated, and the value will have the count of how many times the random number has been produced. So this loop will run for 1,000 times, and it will count like for the first iteration. Suppose if we get the random number 5, so this hash map will create an entry whose key will be 5 and count will be 1. So in another iteration, if again 5 is generated, we increment the value of the count to 2. If the random number 6 is generated, so we create new entry with the initial count of 1. Okay, I guess this is clear. Let me run this program. This program will run 1,000 times this loop. Okay, we don't need this. Okay, so here we can see this program runs this, like, I mean, this random int function generates number only between 1 and 20. This is correct. And looking at this pattern, I mean the count of how many times this particular random number were generated, we can see that they are almost symmetrical. I mean, there is no huge difference between any two numbers. We can run this iteration, let's say 10,000 times. Okay, and let's see, because like if we run this program like 20 times or 30 times, it may not give us a nice result. So let's run this 10,000 times. So okay, so we can see that the least any number occurs is around 440, I guess, and the maximum is what 547 or something. Yeah, so this random number generator is working well. Okay, I'll just scroll through this code once. This is the main function that we are trying to generate. This is a helper function which translates this random boolean generator into random 0 1 integer generator. So this is how it works. You can like write in comment if there's any other better way to do this, better and a short way, because the main objective of our program is to generate the random number. We don't want to spend more time in like converting this binary number into decimal number. Like I can write a for loop and multiply the number by like 10 and whatever thing, and I can generate a decimal number, but that will be little time consuming. So I just used a hack to use another function which was not meant for converting a integer. It was meant for converting a string from binary to decimal. So if there's any other better way of doing this, faster way, more optimized way of doing this, or testing this code, please write it in the comment or send me a message, whatever. Any feedback will be very helpful for me and for the other viewers as well. So that's it for today. Thank you so much for watching the video.